Hi, Dr. Amiza. We are from Group 4, Section 3. Today we are going to present our project to build a pedestrian bridge. First of all, let me introduce my group members. They are YI SHAN, KOOI YI XUAN, and me, myself, MELODY ONG CHELSEA INEZ ARAN KONG, and MELODY ONG HUEI QIE. Our company name is CKLM SDN Bridge, and this is our company logo. Below is our company details. Now let me introduce our project. After having site visit, we decided to build a pedestrian bridge at Kampung Sawah Paya Redah. The purpose of building this pedestrian bridge at there is to let the Pago citizen cross the road from Masjid Jami' Paya Redah to the Roti Canai Paya Redah or vice versa conveniently.
Hi, my name is KOOI YI XUAN, and now I will be presenting the design concept. On the left here, you can see is our 3D design of our bridge. The design concept of our bridge is a truss bridge. A truss is made up of numerous individual components that work as a group to accomplish tasks in tension or compression. The material chosen will be steel in this case and will be discussed more on the next section. And in the next part here, I will be talking about the methodology. First of all, we did a team discussion including cost, material, and also location. We continue with our site visit to confirm our location, and then we start with the statically determinant calculation to make sure the bridge that we are building is stable. And then we sketch out our bridge and also using a piece of paper and also AutoCAD. Next, we follow up with a calculation which is truss, beam, piers, manually and digitally. We calculate it digitally by using StatPro. And finally, we finalize our cost and start building the bridge. In this part of the analysis, we are supposed to check if the bridge is statically determinate or not. So the formula that we are using is m plus r equals to 2j. And from our calculation, we can see that it is statically determinate.
A very good day. I speak to Dr. Amiza. My name is YI SHAN. Now I will continue our presentation about analysis of load. Before we calculating the truss and beam, we will do the analysis of load. The slide is showing the calculation of analysis of load. For the analysis of load on beam, we will calculate the total load of light load and dead load. However, the analysis of load on truss, we will only consider the dead load. After analysis of load, we will continue the calculation of truss. The method we use to calculate the truss is method of joint. This slide is showing the calculation of truss on each joint, which is joint A, joint J, joint I, joint B, joint E, joint F, and joint G. The calculation of remaining joint, which is joint D, joint C, joint L, joint K, joint M, and joint H, is showing on this slide. On joint H, we will use to calculate the balancing of member of joint, and we can see that the calculation is balanced due to there is equal for right side and left side. After that, we will determine the shear force and bending moment, acting on the beam by applying an equilibrium analysis on the beam portion. A free body diagram is drawn so that it is easier to find the shear force and bending moment. On this slide, we are showing the shear force diagram and the bending moment diagram. The maximum shear force is 646.369 and the maximum bending moment is 335.61175. After that, we will determine the diffraction of beam by using mechanical function. Before we calculate the diffraction, we need to determine the boundary condition, which is x equal to 0, y equal to 0, and x equal to 9, y equal to 0. Then we will cut the beam at the last statement and find the moment on it. Since EI d square y dx2 is equal to moment, so we can replace it and integrate it to EI dy dx and then EIy. Then we'll apply the boundary condition on it. For the first condition, we'll let us find the C2. For Macquarie function, if x value is equal to negative, so we can consider it to 0. Then we'll continue for the condition 2. After finding all the constant, we can determine the diffraction on point C. Then we will find it EI y equal to negative 7068.202, and the maximum slope is 633.764.
Good day, Doctor. I am Melody, and now I will proceed for the beam session. For this pedestrian bridge, we will consider by using the I-beam. This is because the I-beam can be less expensive than other type of beam, such as regular beam, which require more material to make a beam with a larger surface area. And the second reason is to reduce the weight of the structure by up to 20% to 30%, thereby reducing the risk of structural or support collapse. And the second part is the section property. We will taken the beam as W24 and the size is 24 times 12 inch and it is 610 times 305 mm. Thank you. Next, I will discuss about the moment of inertia. Here we will divide the I-beam as three parts, then we get the area, the Y, X, AY, and the AX. And the total area we get is 18381.12, and the total AY is the 5325.01 times 10 power of 3, and the AX is 2801.283 times 10 power of 3. And we will get the X bar and the Y bar, which is 152.4 mm and 289.7 mm. And then the second part we will calculate for the ISX, which is the area, the IX, D, and the AD square. And we will calculate for the total ISS, which is 5802,554.987 times 10 power of 3 mm4. And the last part we will calculate for the IYY, which is the area, IYS, and the AS squared. And the total IYY we get is 93047.582 times 10 power of 3 mm4. And here we will take the biggest value of moment of inertia, which is 5802,554.987 times 3 times 10 power of 3 mm4. Thank you.
For the part of section modulus, we're using I over Y, which we get the section modulus of IXX is 20,000 and 29.53 10 to the power of 3. For the part IYY, which we get 321.186 10 to the power of 3. For bending stress on beam, we need to use the maximum moment time y top over the moment of inertia, which we get 0.162 megapascal. And for the bending stress of bottom, we need to use the maximum moment times negative y top over the maximum value of moment of inertia, which we get negative 0.162 megapascal. This is how we calculate the limitation of Euler's theory or critical stress. We're using IXX, which is 5802.555 10 to the power of negative 6, and the total of IYY, which is 930.476 10 to the power of negative 6. To determine the critical load, we need to pick the lowest I, which is 930.476 10 to the power of negative 6. In order to calculate the critical or maximum axial load, we need to use pi square EI over L square, which we get the answer 73,467.44 kilonewton. The critical stress we get is 102.720 megapascal. which is less than 250 megapascal. So the Euler's equation is appropriate.
This is the table for our cost analysis, and the total estimated cost for this project is 1.25 million. So in conclusion, by separating pedestrian and vehicle traffic can ensure the safety of the road and prevent accidents. We believe that building a bridge at Kampung Sawah Paya Redah will bring convenience to the residents who stay at there. That's all from our group. Thank you.